Hello grade 9, so here is your reviewer for math. Question: identify the value of a, b, and c in the quadratic equation r squared equals 3r. So we have to rearrange the terms into the form ax squared plus bx plus c equals 0, or the so-called general form of a quadratic equation. So from r squared equals 3r, so make sure that the right side becomes 0. So we have to transpose 3r to the left side of the equation. So 3r minus r squared minus 3r, and the right side is equal to 0. And as you can see, we don't have a constant term, or the term which is intended for c. So we just have a is equal to the numerical coefficient and the leading term, or the quadratic term here, so 1, and b is negative 3, and c is equal to 0 because we don't have a constant term. Okay, next question. Express x squared plus 4x minus 12 in factored form. So this quadratic expression here can be expressed in its factored form by using the product of two binomials. So we have to factor this as product of two binomials, where the factors of x squared is x and x, and the factors of negative 12, the constant term. So think of the factors of negative 12 such that if you add those two factors, the sum is positive 4. So let's try positive 6 and negative 2. So that if you add them, or you multiply the inner terms, that's 6x, and the outer terms, that's negative 2x, and if we add these two, that's 6 plus negative 2, that's positive 4x, which is exactly this middle term here. So therefore our factoring is correct. So this is the factored expression for x squared plus 4x minus 12. Next, express the equation that will represent the area of a square with side x. So remember that the formula to get the area of a square is equal to s squared, where if we sketch the figure for a square, all the sides labeled as s, they are all equal. So in this case, the area with side x, so all the sides are x, then could be x squared. Area is equal to, or a is equal to, x squared. Next question. The statement the solution of x squared equals 64 is 8 is not true, because aside from positive 8, there is another solution for x squared equals 64, and that is negative 8, because if we extract the square root of both sides and solve the roots of this quadratic equation, then I know this is 64, sorry. So x is equal to positive and negative. The square root of 64 is positive and negative 8. So this is not true. Next question. Find for what values of x will make the equation x squared equals 5x minus 6 equals is true. So we can solve the values of x here or the roots of this quadratic equation by method like factoring, or by quadratic formula, or by completing the square. Extracting the square root is not a practical method to use here, so we just use factoring. But first we have to arrange this first into its general form. So we have x squared. This linear term here, 5x, should be put in the left side now, so we transpose and it becomes negative 5x, and also negative 6 becomes positive 6 is equal to 0. Now let's think of the factors of x squared and the factors of 6. So first, x squared has factors x and x, and the factors of 6 could be 3, positive 3 and positive 2, or it could also be negative 3 and negative 2, but we have to choose negative 3 and negative 2, because if we add this uh, the product of the inner and the product of the outer terms, we could have the negative 5x. So therefore, we can solve the values of x. So we have to erase using the factors x minus 3 and x minus 2 equals 0 by just equating each factor into 0. So x equals 3 and x is equal to 2. So these are the answers. Next question. What describes the nature of the roots of a quadratic equation? So the nature of the roots of a quadratic equation can be described by the discriminant. What is discriminant? Okay, discriminant is the term used for b squared minus 4ac, where b, a, and c can be obtained from the general form of the quadratic equation ex squared plus bx plus c equals 0. So there are natures of roots that is being described by the discriminant. We have the real, rational, and equal, or if the discriminant is equal to 0, the nature of roots is real, rational, and equal. If the discriminant is greater than 0 and at the same time it's a perfect square, then the nature of the roots of the quadratic equation is or are real, rational but not equal. Real, rational, but not equal. And if the discriminant is let's erase this, is greater than 0 but not a perfect square, then the nature of the roots that can be solved from the quadratic equation are real, irrational, and not equal. But if the discriminant is less than 0, then the quadratic equation has no real roots. Okay, now let's move on to the next question. The discriminant of the equation is 2. So how do you describe its roots? Okay, so since 2 is not a perfect square but it is greater than 0, then the nature of the roots are real, but they are irrational, and at the same time they are not equal. So the roots that can be solved from this quadratic equation having a discriminant of 2 are real irrational, meaning they can no longer be simplified, and they are not also equal. Another, identify the characteristic of the roots of the equation x squared equals 144. So, using the discriminant b squared minus 4ac, then from our equation x squared equals 144 transpose, we have to arrange our equation first in the form general form of a quadratic equation. So x squared equals 144 can be arranged as x squared minus 144 is equal to 0. So our a here is 1, b is 0, and c is negative 144. So by substitution, b is 0, 0 squared minus 4, a is 1, and c is negative 144. And we can simplify it as 4 times, because 0 squared is still 0, 4 times 1 times 144. So as you can see, 4 is a perfect square, and also 144 is a perfect square. So this is greater than 0 and at the same time a perfect square. So therefore, the characteristic of the roots of this equation are real, rational, but not equal. So we can write them as real, rational, and not equal. And this makes sense because if we extract the square root of both sides to solve for the roots of this quadratic equation, then we can have x is equal to positive and negative 12. So the roots are 12, negative 12, and positive 12. Real numbers, rational because they can be expressed as quotient, and they are not also equal. Take note that negative 12 is not equal to positive 12. Next question. Which of the given equations has no real roots? So, to identify which of the given equations has no real roots, then let's try one by one. So, from letter A, b squared minus 4ac, using the discriminant, we have b is 11, or no, that's 10, sorry. So let's try letter A. B squared minus 4ac, and b is negative 10 squared minus 4a is 1, and c is negative 11, and 10 squared is 100 minus negative 4 times 1 times negative 11, that's positive 44, and that's 144. And as you can see, this is a perfect square and at the same time greater than 0. So the roots of this letter A option are real, rational, and not equal. So let's try again another. Let's try letter B. Negative 5 squared minus 4 A is 1 and C is 7. So negative 5 squared is 25 minus 28. Negative 5 squared is 25 minus 28. So that's negative 3. And negative 3 is less than 0. We have discussed earlier that if B, or I should say D, if D is less than 0, then the quadratic equation has no real roots. Okay? No real roots. Next question. So the answer here, by the way, is letter B. Okay, next question. Determine the sum of the roots of the equation s squared minus 1 half s plus 1 over 16 equals 0. So, you know that the formula for the sum of roots is negative b over a. But from our quadratic equation, our b is negative 1 half over our a is 1. So that's 1. Yan. So negative times negative is positive, and number divided by 1 is just the same number, so it's still 1 half. Therefore, the sum of the roots of this quadratic equation is positive 1 half. Okay, next. Find an equation with the sum of roots equals 8 and product of roots equals negative 7. So we have a short method to solve this. If we are looking for the equation and the givens are the sum of the roots and the product of the roots, and that is x squared, we start with x squared minus the sum of the roots plus the product of the roots equals 0. So x squared minus sum of the roots is 8x plus product of the roots, that's negative 7. So we just have to rewrite negative 7 equals 0. And yon, ito na yung equation natin kapag ang sum of roots ay 8 at negative 7 yung product niya. Okay, next. Identify the sum and product of the roots of the equation w squared minus 36. Again, gamitin natin yung formula na ang sum ng roots ay negative b over a at ang product naman ng roots ay c over a. So, from that, ang b natin dito sa given na quadratic equation ay 0 kasi wala tayong nakikitang linear term. So, 0, negative 0 divided by a, which is 1, is still 0. So, 0 yung sum of roots niya. Sa product naman, c over a. So, ang nakikita nating constant term or yung c ay negative 36 over 1. So, simplify natin. Ganun pa rin. Negative 36 divided by 1 is still negative 36 pa rin. So, therefore, ang sum and product of roots ay 0 and negative 36. Sum is 0, product is negative 36. Okay, in this next question, transform 3 over x minus x over 4 equals 2 into standard quadratic form. So, gagawin natin siyang nasa form na uh, a x square plus bx plus c equals 0. Kaya ito, dahil mayroon siyang denominators, so i-rewrite natin 3 over x minus x over 4 is equal to 2. So first, i-eliminate natin yung denominators. So eliminate the denominators by multiplying the whole equation by the least common denominator. And in this case, as we can see, x and 4, yung mga denominators, i-take na lang natin sila. So we have 4x. Then, multiply itong LCD sa lahat ng terms na nasa loob ng parentheses. So we have 3 times 4x over x. So, makakancel na yung x at yung x na nasa LCD. Ang maiwan na lang ay 12. Kasi 3 times 4, itong 3 na yan, at saka yung, itong 4 at saka 3. Minus, okay, dito naman, sa next term, x over 4. So, makakancel na rin yung 4 sa denominator at yung 4 sa LCD. So, ang maiwan na lang na mag-multiply ay yung x dito at saka yung x sa LCD. So, we have x squared na lang equals, dito naman sa right side of the equation, say 2 is to be multiplied with the LCD na 4x then. So, that's 8x. Now, i-arrange natin yung equation na nabuo sa standard form. So, i-erase ko muna. We have 12 minus x squared equals 8x. So, dapat magkakasama yung mga terms. 0 lang sa other side. So, cx squared ang i-transpose natin para positive yung results. So, that's x squared. Siyempre, mauna yung quadratic term. Tapos, sunod si linear term. So, 8x. Then, last si constant term. Magta-transpose siya. So, negative 12 equals 0. And we can interchange the terms. So, pwedeng dalhin na lang sa left side yung mga terms. At saka sa right side naman yung 0. And this is now the equivalent standard quadratic form of our rational algebraic equation here. Yan.